Everyone, today I am going to discuss the Bagalkote district first PUC midterm exam previous year question paper. Only I am going to discuss with the MCQ and fill in the blanks. Let us discuss with the first question. The significant figures of the multiplication 2.5 into 1.25 are. Okay, the correct answer is 2. How I got the 2? See here, 2.5 into 1.25. See, how many significant figures are there here? 2 significant figures. Now, how many significant figures are there in this 1.25? 3 significant figures is there. Okay. Now, which is the lowest significance you will get whenever you are going to multiply? That is your correct answer. Now, this 2 is the correct answer for this value. One more example I will take. Let us take with 1.375 into 1.3865. Okay, now let us check with how many significant figures are there. Directly you can write this one by which is the lowest significant is there, that one you need to take. See here, how many significant figures are there means 4 significants. Now how many significant? 1.3865. Okay, 5 significant figures are there. Now they will ask the question, significant figures of the multiplication 1.375 into 1.3865 means correct answer is 4 significant figures. I think clear this answer. Next move on to the second question. Second question is the empirical formula of the glucose is. They are given the 4 option. In that option C is the correct answer, that is CH2O. How we will get the CH2O? First, they read the question properly. They are asking not the molecular formula, they are asking the empirical formula. First, we need to know what is the molecular formula of the glucose. Okay, see, molecular formula of the glucose is C6H12O6. If you know this one, you can easily write the empirical formula. How means? With respect to, we know the formula with respect to this one. Empirical formula is the chemical formula that shows the simplest whole number ratio of atoms in a compound. See, empirical formula says the simplest whole number ratio of the atom. See, this is the molecular formula. What is the simplest ratio with respect to CH2O? Okay, if you multiply with the 6, you will get C6H12, 6 into 12, 6 into 2, 12, CO 6. This is the molecular formula, whereas CH2O is the empirical formula, that is a simple whole number ratio. Same as one more example. See, hydrogen peroxide. How we will write the hydrogen peroxide? H2O2 is the hydrogen peroxide. Okay, see, HO is the empirical formula for the hydrogen peroxide. See, HO I will multiply with the 2. Okay, you will get the H2O2. This is the molecular formula of the hydrogen peroxide, whereas the empirical formula is simple whole number ratio, that is HO is the simple whole number ratio. This is how we are going to calculate the empirical formula. Now the correct answer is CH2O is the correct answer for the glucose. Next move on to the third question. Mass of 1 mole of methane in gram is. See, 4 option is given. In that correct option is option D. How I will get the 16 means, see, they are asking you need to convert mass of 1 mole of methane in gram. Okay, 1 mole is you need to convert the 1 mole of methane in grams. First, what is the formula for the methane? CH4. See, how many carbon? What is the molecular mass? How we need to calculate molecular mass? 1 into 12 plus 4 into 1. 12 plus 4, that is equals to 16. That is a molecular mass of the methane. Now, how we need to convert 1 mole of the methane in gram is, there is a formula to convert the mole of a substance to gram. That is, gram is equals to moles into molar mass. See, how many moles they are asking? 1 mole. I will write 1 into, what is the molecular mass of the methane? That is 16. So answer is 16 gram. Example, if in case of was 1 mole, they are given in the question as an 0.1 mole means same you need to take the 0.1 mole. If they are given in the question 2 mole means you need to take the 2 moles into molecular mass is 16. You need to multiply this one 0.1 into 16. How much you will get? 1.6 gram. If in case they are given 2 into 16 means you will get the 16 to 32. Okay, this is how we need to calculate the mole of the methane in grams. Okay, I think you will clear this answer. Let's move on to the next question. The value of one atomic mass unit is. The correct option in this, option C is the correct option. That is 1 atomic mass unit means 1 AMU is equals to 1.66056 into 10 to the power of minus 24 gram. Okay, this is a direct question. The constant value for the AMU. 1 AMU is equals to 1.66056 into 10 to the power of minus 24. Next, move on to the next question. The number of neutrons in bromine 80, 35. So, the 4 option is given. The correct option is 45. Option B. How we will get the 45? See, bromine having the mass number is 80. Okay. What is mass number? The number of protons plus neutrons is called as a mass number. What is atomic number? Atomic number is given as in 35. The number of protons is called as an atomic number. Now, how we need to calculate this one? Take the mass number is equals to proton plus neutron. The mass number they given 80 is equals to proton. We know that is 35 plus neutron. You will get 80 minus, you can take this one, 35 is equals to neutron. So 45 is equals to neutron. This is whatever the elements they given, you need to calculate and follow these steps. This is how we need to calculate the number of neutrons in the bromine is 45. I think this one is clear. Next, move on to the next question. Question number 6. Azimuthal quantum number I is equals to 1. The number of p orbitals are. See, we know one rule, that is 2i plus 1 rule. Means azimuthal quantum number we are represented by the letter I. They are given that is equals to 1 means what is the number of p orbitals. See, if I take the example 2 into, if I take the I is equals to 0, how much I will get? I will get only 1. Okay. If I say, they are given in the question 1, I will take 2 into I value is in 1 plus 1, that will give us 2 plus 1, that is equals to 3. Okay. See, number of p orbitals are 3. Same you can calculate with the 2 into 2, which if I take I value is 2 given means 2 into 2 plus 1, that is equals to 5. Like that you need to calculate. Next, move on to the next question. The number of elements in the third period are. So correct answer is, guess the answer. The correct answer is option C, 8. See, you need to take, we know the what is period and what is row. Whatever we are placed in the periodic table, whatever we are arranged in the horizontal manner is called as in period. 7 periods are there. Whatever we are arranged in the vertical manner, that is called as in groups. These are the groups. These are the whatever we are arranged in the horizontal manner, that is called as in period. Okay, we know that already there is a 7 periods are there and 18 groups are there. Okay, now what is the question? The number of element in the third period. If you take the first period, how many elements? 2 elements. Which are those? Hydrogen and helium. Okay. Next is in the second period there is a 8 element. In the third period also there is 8 elements are there. So correct option is option C. Now tell me, in the fourth period how many elements are there? Guess it. That is correct, 18. In the fifth period also 18 elements. In the sixth period 32. You need to double this one, and also in seventh period 32 elements are there. This you need to remember. 2, 8, 8, 18, 18, 32, 32. This is in the first period 2 elements. Second is 8. Third period 8. Fourth 18. Fifth 18. Sixth 32. 7th 32. This is how we need to find out the number of elements with respect to the period. Next, move on to the next question. Question number 8. Choose the amphoteric oxide among the following. First, we need to know what is amphoteric oxide. See, amphoteric oxide. The metal oxide which react both with the acids and bases. These are the metal oxides, okay, which react with the both acids and bases, and it will forms the salt and water, that is called as an amphoteric oxide. Are you got this one right? See, these are the amphoteric oxide or the metal oxide which will react with the acids and also with the bases to form the salt and water is called as an amphoteric oxide. I think this one is clear. Example, see, I will give the example. ZnO is an amphoteric oxide, lead oxide is an amphoteric oxide, stannous oxide is an amphoteric oxide, and aluminium trioxide is also amphoteric oxide. So the correct answer is option number A. Al2O3 is an amphoteric oxide. Next, move on to the next question. The nature of the bond in CaF2. See, one thing you need to remember, Ca is the metal, whereas F2 is the non-metal. Okay, it forms the one thing is it forms the ionic bond and also it forms the covalent bond. So option is given with respect to the covalent bond. Option B is the correct option. Next, move on to the 10th question. Which of the following as an trigonal bipyramidal geometry? See the option NH4. See, NH4 and H4. This is structure I written here. This NH4, what is the geometry? This one, this is called as an tetrahedral. Okay. Next, move on to the SF6. See the structure of FS6 I written here. This is a structure called as an octahedral structure. Next, see the BF3. That is the structure of BF3 is trigonal planar. Next, we need to take the PCl5. See the PCl5 written here. This is the structure is called as an trigonal bipyramidal. See the C chlorine atom you need to written here. This is a trigonal bipyramidal structure. So the correct option is option number 4, means D is the correct option, that is PCl5. NH4 is tetrahedral, SF6 is octahedral, BF3 is the trigonal planar, PCl5 is the trigonal bipyramidal geometry. Next, move on to the next question, question number 11, that is bond order of helium molecule is. Okay, you need to calculate the bond order of the helium. See, helium molecule, not an helium atom. Okay, helium, it is having the 2 is an atomic number, and helium molecule He2 is an with respect to 4 is the atomic number. How we need to take this one? How we need to write? See, we know that how we need to write the electronic configuration sigma 1s2 in the molecular orbital sigma star 1s2. Okay. For this one, calculation of the bond order, we know the formula, that is bonding molecular orbital minus anti-bonding molecular orbital divided by 2. See the bonding atomic orbital, this is a 1s2 is the bonding atomic molecule, that is 2 minus anti-bonding atomic molecule, that is the 2 divided by 2, that is equals to 0 by 2 is 0. So the correct option for this one, option number B, 0. This is how we need to calculate helium molecule. Same as you can calculate for lithium, oxygen molecule, same bond order. You can use this one molecular or bonding molecular orbital minus anti-bonding molecular orbital. Next, move on to the question number 12. The first organic compound synthesis from the inorganic compound E. So correct option is option number B, urea. This is the first organic compound synthesized from the inorganic compound. It is given by F. Euler or Frederick Euler. Next, move on to the 13th question. Among the following, select the aromatic compound. See, options are benzene. I written the structure here. See the structure. This is a benzene structure, and ethane, ethene and cyclopropane. Benzene, ethane, ethene, cyclopropane. See, some rules are there to obey the aromaticity. For that one it has to be have the conjugation in the system, and second point, it has to be obey 4n plus 2 pi electron rule. Okay, if it is rule is obeying means conjugation, and 4n plus 2 pi electron it is obeying means that is called as an aromaticity. Okay, so if you take the benzene, it is having the alternative, you need to see a alternative single, and this is a single bond and double bond. Okay, that's why this benzene is called as an aromatic. See, ethane, there is no conjugation. Ethene also, sorry, this is the carbon-carbon double bond. And cyclopropane is not an aromatic compound. So correct option is option number A. Benzene is the correct option. Next, move on to the next question. Name the purification method to convert the solid organic compound into gaseous compound. So, which process? 4 options: crystallization, sublimation, distillation and chromatography. See, the conversion of the solid material directly into the gaseous material means we are going to do the method that is called as a sublimation. The option B is the correct option. Next, the last question, the estimation of halogens by. Okay, see, we need to estimate the halogens quantitatively by which method? Means first, this is the option. In the Dumas method, we are going to estimate nitrogen, and in the Gildal process, we are going to estimate same nitrogen here also. And next, in the Liebig's process, we are going to estimate carbon and hydrogen. So Keyres method is the method we are going to estimate the halogens. That is, halogens of fluorine, chlorine, bromine. These are the things we are going to identify or estimate quantitatively. Okay, next, move on to the fill in the blanks. First question is, dash is an example for non-linear molecule. Before going to question, I will read the option first. sp3, propan 2-one, oic acid 2 water. Okay, see, dash is an example for non-linear molecule, that I will take the water. Why water? See the water. What is the structure of water? This is the water. Okay, it is having 2 lone pair of electrons also. See, what is the shape of this one? This is the shape as in bent shape. Okay, why water is called as a not and linear? Because it is somewhat lone pair of electrons is there. That's why it is a bent shape. It is an angle 104.45 degree. Okay, see, in this if you take the linear structure, I will write one example A. Okay, B, B, like this is just I taken as example. See, what is the angle of this one? A linear molecule angle is 180 degree, but if you consider the water, it is having the not and linear, it has to be taken as an bent. Okay, it is having the angle 104.45, whereas the linear molecule, it is the angle as in 180 degree. Now the correct option is option water. Okay, water is an example for non-linear molecule. Next is second 17 one. Hybridization of the central atom in NH3 is. Okay, see the NH3. This is what is the hybridization, that is sp3 hybridization. So correct option is sp3. Next, read the next question. The suffix of the used in the carboxylic acid functional group. Okay, we know for the carboxylic acid we have suffix we are going to use as oic acid, aldehyde Al, ketone ONE, all wall. Example, see, if you are having the propane is there. Okay, this E is replaced by oic acid, that E is replaced by Al, the T is replaced by O. If the molecule has an alcohol means E is replaced by OL, like that we are going to write. See, the correct option for this one is called as an oic acid. Next, move on to the 19th question. Das is an IUPAC name of the acetone. See, acetone, I will write the structure. This is called as an acetone. Okay, give the name 1, 2, 3. 3 means propane, right? Usually we will write propane, 3 molecule. Now I will just replace the E, and instead of E at the second position, okay, see the second position, the function group is ketone is there. That's why I will use 2-one. See, I written right, ketone one you need to use. So correct option for this one is an propane 2-one. Next, last question, 20th question. The number of bond in the acetylene are. See, this is the structure of an acetylene. See the bonds here. See, with respect to the CH, okay, 1 bond is there. I will write one more time. This is the acetylene structure. Okay, see how many sigma and pi bonds is there means I will tell in this 3 bonds. Whenever the carbon having 3 bonds, in that 2 pi bonds is there, 1 sigma bond is there. Okay, see in this 2 pi bond and 4 sigma bonds. Okay, 2 3 sigma bonds. Okay, 2 pi bond, 3 sigma bond, total 5 bonds are there, but they are given in the question 2. Why I taken as in 2 kinds of bond, one is pi bonds and one is sigma bond. So I will directly take with the 2. The correct answer is 2. Okay, is there any doubts in this questions? Please comment in the comment section. Thank you.